Hello, class. In this video, we're going to talk about graphing systems of linear inequalities. Now, it's no different than graphing systems of equations. So here, we're going to start with our y-intercept. That's -3. So 1, 2, 3 right there. Okay. And then our slope is 2 over 1. So it's up 2, right 1. Now, this equation will be a dashed line because we have no equal sign here. So try the best I can to keep this as neat as possible. Not looking too bad. All right. Now, in terms of shading, I'm not going to shade yet because what we're going to get is an overlapping region, and I want that final overlapping region to be what gets shaded. If you recall, we had a couple problems in our last set of notes where we graphed two inequalities, and the whole shading situation was a mess. So we have to decide, okay, is 0, 0 a viable solution? Well, we plug in 0 here, it's going to eliminate it. So 0 less than -3. No. So instead what I'm going to do is indicate that I need to shade in this direction, okay? And again, I'm not going to shade quite yet. Let's go ahead and graph the second one. This is our x and y intercept method. So x-intercept, we're plugging in 0 for y, so we get 2x. For this, again, we can switch it to equals for the time being. So divided by 2, x equals 1. And then for our y-intercept, we get y is equal to 2. So both of them are, or no, sorry, y is equal to 2, x is equal to 1. So x is 1, y is 2. And now this, once again, is also a dashed line. So let's go ahead. There we go. There we go. All right. Now figuring out what direction this is shaded. So 0, 0 would cancel everything out on this side. So I have 0 greater than 2. That's not true. So I want to shade in this direction. So for final shading, I notice that I'm shading in this direction and this direction. And so the overlapping region would be here. So where we found out last time, if we're graphing one inequality, we split the page in two. When we have two, we're more or less dividing it into 4 pieces. Well, and that can change based on the situation, but this time it was 4. We just got to figure out which one of the 4 are we shading. All right, so go ahead, try the you-do on your own, okay? I'm going to come back to this at the end of the video, and you'll be able to check your answers. Okay, so let's go ahead. Determine if the given point 3, 0 is a solution to the system of inequalities. So generally, we always want to pick points. We don't always pick points that are 0, 0. So what happens when we don't pick 0, 0? Well, here's one that's 3, 0. Well, let's go ahead and plug 3 in for x and 0 in for y. So 0 is less than 2 times 3 minus 3, and simplify. So we got 0. 2 times 3 is 6, minus 3 is 3. 0 is less than 3, so this checks. Okay, so we're good so far. But when we want it to solve the system of inequalities, we want to check both out. So this is going to be 2 times 3 plus 0. Is that greater than 2? 2 times 3 is 6, plus 0 is still 6. 6 greater than 2. So this checks out. So they check out in both. So 3, 0 is a solution. Okay. If one of them didn't check out, then it would not be a solution. So one more time, go ahead, give the you-do a try, and we'll check back on it at the end of the video. Okay, so you are planning what to do after school. You can spend at most 6 hours daily playing basketball and doing homework. You want to spend less than 2 hours playing basketball. You must spend at least 1.5 hours on your homework. Write a system of inequalities. Now, the idea here is we're going to write the inequalities from scratch. We got to first identify how many should we probably be writing. Well, we know they want to play basketball, and they can spend less than 2 hours doing that. Okay. and at least 1.5 hours on homework. But for total, they have at most 6 hours. So that sounds like 3 inequalities to me. So let's define some variables. I'm going to go ahead and define X to be my basketball. Generally, I like to just go with X and Y. If you want to go B for basketball and H for homework, go for it. So Y is homework. Okay. So you can spend less than 2 hours just playing basketball. So that's basketball alone. So that means X has to be less than 2. So that right there, that's one of my 2 inequalities. Or sorry, one of 3. You must spend at least 1.5 hours. So at least is always greater than or equal to. That you're going to want to memorize. So Y is greater than or equal to 1.5. Okay. And then spend at most 6 hours. Now, this is a total. So we got to think our basketball time plus our homework time needs to add up to be at most 6 hours. Well, if we take what I said into words and put it into our variables, our basketball plus our homework, so that's X plus Y, is at most. At most will be less than or equal to. So less than or equal to 6. And there is our system of inequalities. One more time, go ahead and give the you-do a chance on your own. And after this, we will go over the 3 you-dos together. Okay, so the first you-do, I plotted the y-intercept at 5, and then it's down 1, right 1. And then if you use the solution, the checkpoint 0, 0, you get 0 is greater than 5, which is not true. So I drew my arrows away. Okay. And then negative 3x plus y. So the the y-intercept is very clearly 4. If we take this out, then we end up with 4. Okay. But when we do the x-intercept, notice it's going to be negative 3x equal to 4. And we divide by negative 3, and we get x equals negative 4 over 3, which would be negative 1.3 repeating. So I drew that there, and then I drew it. And then if you use the test point 0, 0, 0 on the left side, 0 is less than 4, which is true. So I would shade towards the point. So this whole area right here. And then the overlapping region, if I see, I would shade in this direction and in this direction, would be this blue area right here. Now, for the next you-do, I did go through both solution sets just to kind of show you what happens with a problem like this. 5 is greater than or equal to negative 2 plus 5. Negative 2 plus 5 is 3. 5 is not greater than or equal to 3, so that's not true. Now, at this point, you could just say, okay, 2, 5 is not a solution. It has to check out both inequalities for it to be a solution. But since it didn't work out on this first one, then it's not a solution. I did go ahead and show you the other one. Negative 3 times 2 is negative 6, and then plus 5 gives us negative 1. Negative 1 is less than 4, so it does check out for this particular one. But this just kind of shows you the grand scope of it. Checks out on one, but not the other, then it is not a solution. So the scenarios in which it checks out on one, but not the other, is not a solution. And if it didn't check out on either, then it obviously wouldn't be a solution. And then for our last you-do, you want to build a fence for a rectangular dog run. You want the run to be at least 10 feet wide. The run can be at most 50 feet long. You have 126 feet of fencing, right? A system of inequalities that represents the situation. So I've got X as length and Y as width. And I even drew a diagram. So we're bringing back a little geometry here. Okay. So we got X, X, Y, Y. That's a rectangle. Okay. So it says the run can be at least 10 feet wide. So that's width is Y. At least, we have to remember, is greater than or equal to. So that's Y is greater than or equal to 10. The run can be at most less than or equal to 50 feet long. So the length is X, so that's X is less than or equal to 50. Now, this last one is a bit tricky because you got to remember we're talking about perimeter here. And this is where the geometry aspect of it comes in, is we have two widths in y and 2 lengths in x, and perimeter is when you add up all the sides. So my last inequality would be 2x plus 2y is less than or equal to 126. I will say it doesn't say at most, so we don't know immediately, but we kind of have to infer it. If I've purchased 126 feet of fencing, I can't use more than I have. I would have to go buy more. And we always assume in these problems, well, we're not going to go buy more. We're just going to assume that this is all I'm going to deal with. So that was what we'd have at most, meaning less than or equal to. I can go up to 126. I don't have to use all of it if I don't want to. And so that's how you write out the system of inequalities for that last problem. Thanks for watching.